Okay, so today we are working on lesson 7 problem set, and today's goal is to solve word problems involving volume with rectangular prisms. So we're going to keep in mind that volume formula that we've been using. Volume equals length times width times height. And if the color strategy from last week was really helpful for you, feel free to go ahead and color code those, because if that's a strategy that helps, continue to do that. So we're going to start with number 1. Jeffrey builds rectangular planters. So think of like a garden bed that you would plant vegetables or flowers in. Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of soil in the planter? Explain your work using a diagram. Okay, so I know I have to draw a diagram, and I'm going to go back and read to find the information I need for the formula. So Jeffrey's first planter is 8 feet long, so there's my length, and 2 feet wide, there's my width. The container is filled with soil to a height of 3 feet, so there's my height. So I have all of the information that I need to solve for volume. I need to use a diagram. So drawing rectangular prisms might take some practice if you're not used to it, but this is how I generally do it. I start just by drawing a rectangle. So that would be like the front of the figure. And then I make my diagonal lines, and I try to make them the same length and the same, going at the same angle. And then I just connect those. It doesn't have to be perfect. We're not asking you to measure them and use straight edges, just a diagram. And then I'm going to label. So I'm going to look for my length. My length, if I go back, was 8 feet. So that's how long the front is. So I'm going to label that as 8 feet. Okay, what about my width? Well, the width, it is 2 feet wide. So I'm going to label this side as 2 feet.
All right, Ms. Hall, just while you're going, the visualizer is very blurry for all of us.
I'm sorry. Is that any better?
No.
I'm not sure what to do because it's totally clear on my side.
Your little screen where you're speaking from is clear, but the present mode is blurry.
Did that help?
No.
I'm not sure what to do. Yeah.
Could you exit out? Yeah, and then go back in.
Sorry for the technical trouble today, guys.
It's okay. I mean, we can see it where you're teaching right off your binder. And you guys can, if it's not directly on your screen, you can always pin her screen to your screen. If you hover over her screen, there's a little pin button. Oh, that's much better.
That one's backwards though.
No, but it's much better now, the visualizer.
Okay, great. Okay, so in case you didn't see it, I marked from the word problem that the length, so across the front, is 8 feet. The problem told me that the width is 2 feet. So now I have to find the height. So the container is filled with soil to a height of 3 feet. So 3 feet is how high it is filled with soil. I don't know if the whole container is 3 feet high, but I know the soil is 3 feet high. And that's what they're asking me, is the volume of soil that's in the planter. So we're going to now show how we solve. So I'm going to rewrite length times width times height. And then I'll fill in each of those measurements. So my length was 8. The width was 2. And the height was 3. Okay, so I can either use a calculator and multiply all of those, or I can combine together numbers that go together easily. So then this would become 8 times 6. And then 8 times 6 is one of my basic facts. So 8 times 6 would give me how much? It is Matthew here.
48.
Yep, 48.
Thanks,
And then I have to
Julie.
go back and check my unit. So my unit is feet. Everything is in feet. So I'm going to label it feet. And then put the little 3 there to make it cubic feet. And then since it's a word problem, we do have to do an answer statement. So I'm going to revisit the question. And this kind of goes along with races where we have to restate an answer. So what is the volume of soil in the planter? The volume of soil in the planter is 48 cubic feet.
Oh, Evan was all sad that you didn't bring his turkeys.
Any questions on that one? All right, so now we're going to look at part 2. So Jeffrey wants to grow some tomatoes in 4 large planters. Uh-oh. Okay. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. Show 4 ways Jeffrey can make these planters and draw diagrams with the planter's measurements on them. Okay, so let's think about what this is asking us. He wants to grow some tomatoes in 4 large planters. So these are the 4 planters that are labeled. He wants each planter to have a volume of 320 cubic feet. So that's important. That's what we're looking to create here. But he wants them all to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planter's measurements on them. So can anybody explain what this problem is asking us to do? What's our
See, I'm
goal
looking
here?
for people who want to volunteer. What do you think Jeffrey wants us to do? What is he asking us to do?
Make 4 planters out of 320 cubic feet.
Good job, Amadio.
And so, good job. So to find volume, we're multiplying 3 numbers. So if we have to make 4 different ways to get to 320, what are we really looking for? What do we have to figure out?
Think about working backwards, you guys.
Remember that volume is length times width times height. So all of these have to equal 320 cubic feet. And they all have to be different. So can I use the same numbers here 4 times?
Julie's saying no.
Right.
Melissa
So
saying no.
if I can't use the same numbers every time, what do I have to figure out?
You have to use different numbers for each one.
Yeah, I have to find different ways to get to 320. So what's really important here is to think about ways we can break up 320 so that we can have 3 numbers that we multiply to get to 320. Now, one thing that's standing out to me already is that 320 has a 0 at the end, right? So when I see a 0 at the end, I know that something's being multiplied by 10. And in this case, if I took off the 0, I have a 32. So this is going to help me because now I can break up these numbers into numbers I can multiply to get 32 and 10. So I'm going to do one to start you off. I know that I can break up the 10 into 1 and 10. So I could make a planter.
And right now, everybody
That
should be
is-
drawing the same thing that she's drawing in your planter A.
So I could do 32 for a length. I could do 10 for a width. And then 1 for a height. So for this planter, we would be multiplying 32 times 10 times 1, which is 32 times 10, which is 320. So you can use a number bond to help you split up the numbers. So I can just recreate that number bond and think about what's another way I can break up either 32 or 10. Can anybody think of a way that we can multiply to get 10? I already used 1 and 10, so don't use that one. But is there another way that we can make 10 by multiplying? Is Nathan Harrington with me?
He is. Julie was going to answer, but
Oh, Julie, I'm going to have you do the next one then. Nathan Harrington, what's another way that we can multiply to make 10?
Yeah. Jake is a very difficult person. He is a unique.
Wait, what was your question?
I'm asking, how can I multiply to get 10? What are two numbers we can multiply to get 10?
Yeah, somehow I could see
2
that.
times 5.
Perfect.
good job.
So
Alrighty, well,
for
we'll
this
see you
planter, I
later.
would be using 32, 2, and 5. So I'm going to draw another planter, and I'm making these longer because 32 is a bigger number. But they don't have to be, perfect. Just do your best. So then I'm going to label this. I'm going to use a length of 32 feet. I'm going to use a width of 2 feet and a height of 5 feet. So it might look similar to the one I drew here, but my numbers are different because for the planter A, I used 32 times 10 times 1. For B, I'm doing 32 times 2 times 5. And then I'm just going to show my thinking with my multiplication formula. And again, I want to combine things that easily go together. I know 2 times 5 is 10, so that's an easy one to combine first. And multiplying by 10 we like to do because you just pop a 0 onto the end of the other factor. So again, we get 320 feet. Before I go on to C and D, does anyone have any questions or want me to review something I did here?
I see shaking heads no.
Awesome. All right. So let's try and think of some other ways that we can make 320 then.
I like this problem because you can be creative with the numbers.
Yeah, me too. Julie, you want to help me out with this one? How can we break up one of these factors?
You can break up 32 into 4 and 8.
Yeah. So if I do 4 and 8, then I would keep the 10. So I'm going to draw another planter.
And now you can see hers is going to be smaller this time because she doesn't have that length of 32 for this one.
So then I'm just going to label them. And it doesn't matter which one I use for length, width, and height. The numbers can go anywhere because your pictures aren't measured out. They're not meant to be completely accurate. It's just a diagram. So maybe I'll say this is 4 feet long, 8 feet wide, and 10 feet high. And then I'll just fill in my formula. So I'm multiplying 4 times 8 times 10, which is, and if I look at my number bond I did here, I easily see, well, 4 and 8 combine to make 32. So in my mind, those are the ones I'm going to combine first. Oh, that becomes 32 times 10. We love to multiply by 10. Pop on that 0. And again, we've got 320 cubic feet. All right, we got one more that we need to fill in.
I have an idea.
An idea. Go for it.
I think 2 and 16 for the 36. I mean,
Great
for the
one.
32.
Great
I was
job,
not thinking
Ava.
that one. Nice job. I was thinking of something completely different. Perfect. All right, so I'm going to draw a diagram here. Okay, so then I'll just label it. I have 2 bigger numbers and 1 number that's much smaller. So I'm going to put my smaller number on my shortest side. So this one will be 2 feet. And then 16 feet is for width and 10 feet for height. And then we're just going to fill in our formula. So with these 3 numbers, 2 times 10. And if I'm not sure which ones to combine, I can go back to my number bond and see, oh, well, I split this number up into 2 and 16. So I can just put those back together to get back to 32. So I can group those together. So I have 32 times 10 again, which is 320 cubic feet. Anyone have any questions or want me to review any parts of my strategy?
And remember, if you have questions, you can always type them in the chat too, because Miss Bloom and I are monitoring that. So if you don't feel comfortable, Nathan's mentioning that it's a little blurry still.
Is that any better?
It seems it to me, but I don't know how it is for those guys.
All right, well, we're going to wrap up. So I can always take a picture of this and post it. Can we have someone explain to us what our strategy was today? Or something we did that you are going to use when you do it on your own, a strategy that you found useful. Brianna, what's something we did today that you're going to try to use?
Drawing pictures.
Drawing the pictures, okay. Anybody else? Ava J, you gave us some good ideas there. What's a strategy that's helping you today?
Ava left.
Oh, is the other Ava here?
The other Ava is here.
Ava Wicks, can you help me out? What's something that we did today that you're going to use?
Number bond the numbers.
The number bonds helped you? Good. Good. All right. So if nobody has any questions, I'm going to stop us there. Be on the lookout for your assignment posted on Google Classroom in just a few minutes. We're not going to do the exit ticket today. You're actually going to do problems 1 and 2 on the homework page. I will post them on assessments. But if you're doing it on assessments, I need you to post the pictures of your work. If that is a challenge for you to do through assessments, please just do it on your paper and send me a picture. Okay. I really want to see your diagrams and your actual work today. So whatever is easier, if you can do it through assessments, do it that way. But if that doesn't work for your technology setup, just snap a picture and you can email it to me. You can attach it to the assignment on Classroom. You can send me a message through Google Hangouts or Google Voice. You can text it to me, whatever works. Okay. Any other questions before we sign off? All right. Awesome job today. You guys did a great job. I can't wait to see your work and see those strategies that you're using.